Parker back in the day, doing robotics. Went to school to study mechanical engineering and then joined FormLabs. So it's grown. It's only been around the company for about 4 years. We're up to about 100 people now. What we do is we produce sort of the world's first prosumer desktop SLA. So let me go into what that actually means. Who here has used 3D printers before? All right, one. Who here knows anything about 3D printers? All right, slightly more. That's good. Okay, so 3D printing is probably a terrible term for this technology. It confuses people a lot more than it explains. Additive manufacturing might be a better way to describe it. So you've probably all seen like a milling machine in the robotics lab. It's more traditional manufacturing. You start with a big block of something and you take away. So it's subtractive manufacturing. This is additive. So what you do is you start with a layer that you deposit, and then you gradually build new layers. And each layer is, you think of a 2D shape with different features, and when you stack them, you can get out any shape you want. So if you think of the most basic 3D printers you've probably seen, you've probably heard of a company, MakerBot. There are several others that do something called fused deposition modeling. And this technology has been around probably about 20-25 years. And what this technology does is you have this plastic filament, and you heat it up, and you extrude it through a nozzle. And you can almost think about it as a very, very precise hot glue gun. And you draw out your layers, so you stack your layers on top of each other. So you can sort of imagine how you would build up any shape that you could imagine through this technology. And over the past 5 years or so, it's gone from being a sort of a DIY thing on a desktop scale to being something that really a lot of consumers and some professionals use as well. They have ones that fit on your desk, they have big ones, they have industrial ones that are hundreds of thousands to millions of dollars. What we do is not that. We use a technology called stereolithography, or SLA, and this has actually been around for longer than the other technology, FDM. And you can get a lot cleaner, smoother parts out of it. So we don't have a filament, we don't have any heat. We use what's called a resin photopolymer. So in here, this is hoop. It's you can see there's some in here. It's gray. We make it a variety of different colors, but the chemistry of it is you start with this liquid, you shine a near UV laser at it, and it causes the resin to polymerize. So you get this really hard part out rather than a liquid. And because you're using a laser or some sort of light underneath it, you get a much, much crisper part. So imagine drawing something with a hot glue gun. It's kind of messy, you have a lot of heat, and where mechanics involved, as opposed to just wherever your laser points, that's what you get. So that's sort of what this machine is, and there's one more added complexity to it, and that it's not just stereolithography, it's inverse SLA, so it actually does everything upside down. So you can see here we printed a part on Saturday at the first event, and you can see it sort of looks upside down. If I were to take this off, you can see that it's a little butterfly pocket clip. And how this printer works is you have this piece called the build platform, and it locks onto here, and it actually drives down all the way to the bottom so that this surface is flush with the bottom of the tank. And you get a very, very thin layer of this liquid resin. With our software, you can make it very thin. You can do 25 microns, 50 microns, 100 microns, but smaller than the width of your hair. So very fine layers. And so what it will do is the laser will drop from the bottom, that first layer, and then the build platform will rise up, and you'll get a new layer of liquid that flows underneath it at the same thickness. So you're going to be building this layer by layer, upside down. Parker, when he demos the software, it will be a little bit more clear exactly how that works. But just sort of the basics around this printer, we have our cover here. This is made of a light blocking material. Anyone have a guess as to why this needs to be a light blocking material? There are two reasons.
Because otherwise you risk activating the polymerization.
Yep, that's one reason. Anyone know the other?
Maybe you don't want the laser reflecting off.
Exactly. So we have to test all these covers to make sure that they actually block the 405 nanometer light that comes out of here. So there's a couple things that you want to be really careful about. You want to never spill resin. Spilling resin is very, very bad. We have this overfill line here. You can see it on the tank. And then there's also 4 posts inside the tank, so when you pour your resin into the tank, you want to make sure that it's never above those lines, because once this build platform submerges, if it's over the line, it will flow everywhere. There are some other things you want to be careful about. If you want to remove this resin tank, you always want to remove the build platform first. The resin, you can see there sort of drops on here, and if it drips, and this guy's out, it'll drip onto the mirror. And the mirror in here is very, very fragile. It's something called a first surface mirror. If you look at mirrors in your homes, you'll see, you have your mirror surface, and then it's covered by a glass or a plastic. Our mirror surface is on the top. So really any touching can destroy the mirror. So you never want to touch it. Occasionally you want to check to see if there's dust on it. And you can actually just do that with your cell phone. You just throw the light on and it will light up if there's any dust. But generally you need to be very, very careful around that mirror. That's the #1 cause for failed prints, and it's very tricky for people who don't know that to keep their fingers off. The same thing goes for the bottom of this. There's an optical clear surface on the bottom. This is just plastic. But you don't want to get your fingerprints onto there. You guys know the company Tesla? So they have FORM1 Plus, and they were getting a ton of really bad prints out. So we went out to San Francisco to visit them and looked at the printer. I'm like, you guys, you know that you got fingerprints all over your resin tank. That's why it's failing. And they felt very embarrassed. So very, very smart people can still have trouble with these. So it's, I guess, a challenge for us to make it better in the future. Yeah. So this is the resin tank. This is the build platform. The guts on the inside, I guess we talked about the mirror. In the back we have this optical engine. It consists of a laser and 2 galvanometers. Galvanometers are sort of some technology that you can use to position the laser. So you have a laser that shoots at a mirror that's controlled by a galvanometer, and we can control it very precisely how that mirror moves. Over the whole course from like left to right, front to back, each of the laser only moves about 12 degrees. So you need very, very precise control over that, and that's sort of how we position it. Did I miss anything on this intro here? Any questions before we jump into software? Yeah.
How do you remove it from the build platform?
We're going to go over that right after we do software.
Okay.
Yeah.
So why you said prosumer? Why is it a prosumer versus a consumer?
Sure. So consumer, I like to see a little bit more in the future. Consumer means anyone can use it, and we sort of acknowledge we're not quite there yet. There's some mess involved. The resin is not something you want kids to play with. Think about it like a model paint. It's really not something you want to get too close to your face, or you don't want to touch it too much. You have to deal with things like isopropyl alcohol. Those aren't really consumer-friendly things. We are working, especially within our software, it's very, very easy to use. You don't really need to think much. You just need a model, and sort of our whole business plan is worry about your parts, don't worry about the printer. And that's sort of why we're starting, we say we're prosumer, because for so many of these other printers at this price range, you have to worry about the printer a lot. There's a lot of tinkering, there's a lot of maintenance and troubleshooting. And with the FormWan, FormWan Plus, I guess, it just sort of works out of the box. There's no calibrating, there's no tinkering, and that's why professionals, so small engineering firms, jewelers, artists, designers, robotics team, anyone who wants really precise parts but doesn't want to lay down $20,000 or $100,000 in a $10,000 a year service contract. That's why people sort of get gravitated towards this machine. The price point for this is $3,400 for printer, finish kit, software, and a liter of resin, which is a little bit higher than a lot of the low-end FDM machines, but not by much. Anything else that can sort of produce at this quality is about an order of magnitude higher in price. So,
So, along with the printer, you need to be able to tell it what to print, and so we provide 3 forms for free on our website. So this you don't need to have a printer to use. You can download it and play around with it if you want. And so, like Craig said, our goal is to make it pretty simple. We don't want you to have to know much about 3D modeling or computer-aided design. Are you using CAD for prototyping your robot designs stuff currently? Okay, so
I'll let you guys answer.
What do you think, Rio?
Okay, I'm actually not familiar with that. It's a CAD program.
Yeah.
Alright. Yeah. So I guess the workflow would be design something in Creo or some other modeling program, and most programs allow you to export as STL files. We also read OBJ files, but they're basically a bunch of triangles, and so our software takes those in, and we need to do a few things. So since the printer prints layer by layer, you need to slice the model and then figure out what path the laser is going to trace to actually cure the resin in each layer. So we have a slider that allows you to preview the model, and if you zoom in, you can see the individual laser paths. So when you tell the printer to print, it'll have the laser trace out the boundaries, and then each of these internal raster paths. But for sort of keeping it simple for people who maybe just download a model from the internet or don't know a lot about 3D printing, the basic workflow is that you import a part, then scale it to the size that you want. We have a tool that will automatically orient the part for you. So one thing, there are some considerations when printing. Large flat surfaces that are parallel to the build platform don't actually come out as well as angled surfaces. It's a result of the SLA process, and so our auto-orienter checks for things like, will you be able to support the part, and how good is the surface finish going to be at that orientation. So if you have, since it's being built up layer by layer, the part's not completely connected initially, so at some layers there might be overhangs. I'm not sure if this model has any, but sometimes if you had a C, maybe the top part of the C has this large gap under it, so when you try to cure that first layer, you get a really thin layer of plastic that won't hold itself in place. So we generate support structures that will make sure that at each layer, each part of the model will stay in place and is either attached to another part of the model or one of the support structures. And you can see those on the butterfly that printed as well. And then, let's see. And then if we had the printer plugged in, at this point, if you're happy with the supports, you can go ahead and click print and send it to the printer. The other thing that you can do is that this generated a lot of supports. As you get more familiar with the program, you can edit the support structures, maybe remove some of them to use a little bit less resin. And so that's sort of something that you have to, that's a way that if you do have some experience with this particular printer, you can use the software in a slightly more advanced way. But generally we're overly conservative, and we want to err on the side of making sure that the print comes out rather than optimizing for resin use or print time.
Cool.
Anything else that you think I should cover?
Maybe why do we need supports in the first place?
Okay. Yeah, so you'll notice that at the bottom there's this, what we call a raft, but it's this, this bottom platform that all the supports are on. That sticks directly to the build platform, so that does a couple things. It makes sure that the part actually sticks to the build platform. If you have a really small area touching the build platform, then it might fall off as subsequent layers get hardened at the bottom of the tank and then get peeled off. And the other thing it does is it accounts for some amount of shrinking of the resin. So the build platform is not going to deform at all, but the resin shrinks a little bit as it cures. So the build platform absorbs some of that and prevents it from cracking or distorting your part. And then the supports that grow out of it are basically to make sure that the model is well attached to the platform, but with minimal touch point size, because everywhere this attaches to the model, you have to break or cut it off. And then the supports will also keep different parts of the model in the same relation to each other. For example, you can do things like print interlocking chains, because while the different parts of the model aren't connected to each other, the supports hold them so that they don't move around while they're printing, and then when you break the supports off, you can have freely moving interlocking parts that were printed as one object.
Any other software questions? Okay, so we'll do a quick demo on how to clean up a part before we start a new one. So this is what we call our form finishing kit. We've got some cool things in here. Got a little spritzer here, so we're going to fill this up with some isopropyl alcohol. We have 2 buckets here. We don't have enough alcohol to fill both of them right now, but we'll just do one because the alcohol's fresh and we'll be fine. Generally what you do is when you take out the part, you can see it's still covered in this liquid resin, and you want to get any sort of this excess liquid off. And that's sort of why we have this whole kit. So what you do is you basically fill it, surround it with this alcohol, and this alcohol will dissolve away the excess liquid. Only the part that you want, the part that you cured, the fillings are remaining. So when the part comes out of this machine, it is fully cured, but there's just extra gunk on it that you want to get off. So some other fun things that come in the kit here. We have a spatula. This will help you remove the part from the build platform. We have these snips, which will remove the part from the support structures. We have this thing. You don't really need this, I guess. Fun story. So if you have a failed print and you have cured bits of resin in the tank still, you can use this to help get those cured bits out. But you actually want to be very, very careful with the tank, and that the bottom is a silicone layer. It's very thin, it's very fragile, and it's very easy to pierce. So you want to be very careful working with that. After about a few liters of resin, you're going to need to replace your tank. I think you have a spare one here, so that's okay. The real story behind this guy is we originally used these to remove support structures, realized they weren't strong enough, and started shipping these guys, and never stopped shipping these guys. So that's why you have this. There's also this microfiber cloth. Use to clean and cover, I guess. Don't put it on the mirrors because it will ruin your mirror. So to start off, we're going to take this out. We also have a lot of gloves that you can use if you want. Because this is the first time I'm using this, nothing's sticky. Hopefully you can keep it this way, but it's sometimes you can do that. And we're going to remove this. So if you look at the base of this, you can see there's a bunch of little caves, they almost look like. You see them on the screen as well. And on this finished kit, you can see that there's a place for this build platform to go. And really what I want to do is sort of wedge this underneath here into one of these caves to sort of just twist this off. And you can see that it's sort of prying up a little bit. And I just want to kind of sink it under there, and so you get very easy part removal. I'm going to put it in here. And what's this? Generally you want to have it soak for a little bit, maybe like 10 minutes with a little bit of agitation at the beginning. And so generally, once you have cured resin, you can dispose of it, it's totally safe. Liquid resin, generally in bulk, you don't want to. Something like this, where I'm just cleaning off the spatula, it's fine to throw this out. I'm going to do the same thing. I'm just going to wipe down the build platform as well, get rid of this excess liquid.
So how bad is it to get this resin on you? It seems like you're taking a lot of precaution to stay away from the resin. Is it like really bad stuff?
It's just because I have experience staying away from it. I bleed resin sometimes. Think of it like model paint, really. So you don't want to touch it. It's sticky. It's not. You need to use a lot of soap to get it off. Yeah. So generally, when you get it on your fingers, you go 3 steps: hand soap, dish soap, Purell, and that'll get it off. You can also again cure it. So a lot of UV light. Go outside in the sun, but we don't get too much of that these days. So yeah, obviously don't consume it. Do your best to keep it off your fingers. We have gloves, that's why you have them. But it's not, really hazardous chemical. And also, if you want, there's a cover for this. So when you're transporting, you'll definitely want to make sure that your build platform and tank aren't in the printer, especially if it's a full tank. If it's an empty tank, that's fine. But this will sort of, you don't want to tip this upside down, but this will make it a little bit resistant to shaking this cover. So I figured while we wait for this to sit, we're going to leave this in here for about 10-15 minutes. We can start another print. Do we leave this on your table overnight?
That's fine with me.
Okay, so let's plug this in. Parker, why don't we set it up on your laptop?
Do you need a long USB or your own?
I think we do. If someone here wants to come up and just try a setup, and we can maybe talk about it. Maybe we do it on that side. Yeah,
Like mine.
No, we have the file.
Oh,
I
yeah.
have the file.
Yeah.
Do you guys have a file?
Yeah, I do.
All right,
For
yeah,
what?
let's get you going.
Nav 6 case.
What are you gonna,
Okay.
I was thinking the nav 6.
Yeah.
The nav 6 case, why don't you print that?
Yeah.
Wait, so can we give you guys a file to print if it's an STL?
Do you have a USB extender here?
Yeah, I think I see this.
I've got a long USB cable, if that's what you want.
Yeah, that'll work.
If we have like a case we want to print, can we just give it to, like, if we have the ST, have we
No, I
have
think
the
I
STL
can
file
unplug my
right now?
computer once we get onto the printer, right?
Yeah, we could run from
Yeah,
the
this-
computer, but if we do it on here, everyone will be able to.
Is this kind of okay or not?
Sure. Or you need
Oh, that'll work.
It's from the file. Yeah. It's on my.
I do have some extenders.
So fun things, you plug in the printer, this button turns it on. You don't actually need to turn it on before you plug it in because the computer will wake it when you send the file. Some other fun tips, so while you're printing, if you need to cancel it, you press and hold the button for 3 seconds. To pause it at the end of a layer, you just push the button once and it will pause at the end of the layer. To pause it immediately, you can just open the cover and it'll stop the laser.
What do you guys manufacture?
We have a contract manufacturer in California, so it's always fun to visit the factory, especially this time of year. Okay, so I'm just sending nav. How's it? Cool. print a bunch, we can fit them all on the go, but depending on how big it is. The buildable area here is about 5 by 5 by 6.5 inches. So really, everything's within that volume we can print. Before you go dive in and use this, I definitely encourage you to go to our support website, which is support.formlabs.com. And there are probably about 20 different pages on that site that go over sort of how the printer works, what types of models we can support, and how you want to set them up to maximize your print success. And you can probably read through it all in less than an hour, and it will really go a long way to getting you up to speed on how to use this printer.
Alright, so I have one thing that it's actually very important that I failed to mention, is you have to tell Freeform what material is in your printer. So it'll prompt you when you start up or load a file